Okay, so this is for Mrs. Cucci's College Now Pre-Calculus class. We are on lesson 3.4, Theorems about zeros, and we left off on page 1.12. So please have that out and open, ready to go. Okay, so what we're going to talk about now is integer coefficients and rational zero theorem. So let's say you have some polynomial. That's what this is. Okay, this is just a polynomial, where all the coefficients are integers. We're going to consider a rational number denoted by p divided by q, where p and q, sorry about that, are relatively prime, meaning they have no common factors besides negative 1 and 1. If p divided by q is a 0 of p of x, then p is a factor of a sub o, and q is a factor of a sub n. So I know that's a lot to understand, but what we're going to do is we're going to go through and see how this works. Okay. So, given f of x equals 3x to the fourth minus 11x cubed plus 10x minus 4, we're going to find the rational zeros and then the other zeros. That is, we're going to solve f of x equals 0. And we're going to factor f of x into linear factors. Okay, so the function we were dealing with was f of x equals 3x to the fourth minus 11x cubed plus 10x minus 4. We want to find the rational zeros. So what we're going to do is we're going to figure out what all of our possible rational zeros are. And the way we figure out all of our possible rational zeros is to find all of our options for p over q. Okay? Now, what that means is we need to think about our factors. So p is all the factors of your last term, which in this case is negative 4. Okay? And q is all the factors of 3, which is your leading coefficient. Okay? So, because the degree of the polynomial is 4, there has to be at most 4 distinct zeros. So what we're going to do is we're going to find all of our possibilities, our p over q. Okay? And our possibilities here, first, p, all the factors of negative 4. So we've got plus and minus 1, plus and minus 2, and plus and minus 4, right? Those are all factors of 4. And then our possibilities for q are factors of 3, which is going to be plus and minus 1 and plus and minus 3. Okay? So, therefore, my possibilities for p over q are 1 over 1, negative 1, 2, negative 2, 4, negative 4, right? 1 over 1, 2 over 2, 4 over 4, over 1. Then we have 1/3, negative 1/3, 2/3, negative 2/3, 4/3, and negative 4/3. So these are all the possible real zeros that could be zeros of this function. So now what we need to do is narrow it down. So the way we're going to narrow it down is to graph the function so we can have a better general idea of what zeros I should go and check, because I don't want to have to check every single one of these. That's going to be a lot of work. Okay? So we're going to real quick hop over to my calculator, and we're going to take this piece here. Okay? And I'm going to add a calculator page, or graph page, and graph the function. Okay, so here's my function. So it looks like maybe I have a 0 at negative 1, maybe 1/2, and in between 3 and 4. So maybe, in between 3 and 4 perhaps. Okay, so we're going to go back and we're going to try and find these rational zeros. All right, so we said the graph kind of looks like this. Okay, and we're thinking maybe -1, maybe +1/2, and then between 3 and 4, but we don't have any values here that would be between 3 and 4. So I'm going to start by thinking about testing these ones. Okay, so remember, the way we like to test is by using synthetic division. So we're going to start with that value of -1. Okay, so here's first step, here's second step, here's my third step. So again, we have our coefficients: 3, -11, 0 as a placeholder for my x squared, 10 and -4. Drop my 3. 1 times 3, -3. Add them up, -14. 3 times -1 times -14 is a +14. Add them up, we get 14. -14 gives me -4, +4, and 0. So we know, since f of -1 equals 0, -1 is one of my zeros. Okay, so that allows me to rewrite this a little bit further factored. Remember, remainder, constant, x squared, x cubed in this case. So 3x cubed minus 14x squared plus 14x minus 4. Okay, so we've got it factored one step further, right? So we're breaking it up into those linear factors. The next one I want to try is 1/3. Well, 1/2 wasn't one of our options, so we're going to do 1/3. We knew it was between 1 and 2. 1/3 will fit that, or between 0 and 1. Okay, so let's try 1/3, and again, synthetic division, right? So 1/3 is going to be what we're going to use, and this time we're going to pull from here. Okay, 3, -14, 14, and -4. Drop that 3. 1/3 times 3 is 1. And this gives me -13. -13 times 3 is -13 thirds. When I add that up, I get 29 thirds. Multiply that, we get 29 ninths. And when I add that up, I get -7 ninths. So this is not 0, which means 1/3 is not a factor. Okay, so that's going to get excluded here. So let's try 2/3. That's in between 1 and 2 as well. All right. So I'm going to try 2/3. So again, we're doing 3, -14, 14, and -4. Drop your 3. This gives us 2. -12. Multiply that, it gives us -8. And that gives us 6. 2/3 times 6 gives us 4, which gives us 0. So we found another factor. Okay? So we had our x plus 1. We now have our x minus 2/3. And then what's left here is 3x squared minus 12x plus 6. Okay? So I see that 3, 12, and 6 all have something in common. I can pull out a GCF there. 3, x plus 1, x minus 2/3, and x squared minus 4x plus 2. All right, so what we've done here is we've factored it as far as we can. Okay, it doesn't get any more factored than that. So the next part, it wanted us to find all of the zeros. So what I'm going to have to do from there is I'm going to have to use zero product rule and set each one of these equal to 0. solve for x. Now the degree of the original polynomial was 4, so we're assuming that there's 4 solutions. So obviously that doesn't work. -1, 2/3. And now this one doesn't factor. So in order to do this, we have to use quadratic formula. So we get x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And this is going to give us a value of 4 plus and minus the square root of 8 over 2, which reduces to 4 plus or minus 2 square root of 2 over 2, or 2 plus and minus the square root of 2. Okay? So, by doing that, I suppose we could take it a step further and say my factored form, because I found 2 solutions here, would be x minus 2 plus the square root of 2, and x minus 2 minus the square root of 2. Okay? And that would be completely factored form. Alright? So my zeros would be -1, 2/3, 2 plus the square root of 2, and 2 minus the square root of 2. And that's 4 of them. And it matches the degree of my polynomial. Okay, so let's do another one of these. And like I said, they're very lengthy, so we'll probably only get through this next one, and then we'll have to have a third day for this video. Okay, so this one wants us to find the rational zeros and factor into linear factors. Okay, so we have my function f of x equals 2x to the 5th, so I already know I'm going to be dealing with 5 zeros, minus x to the 4th, minus 4x cubed, plus 2x squared, minus 30x plus 15. All right, so we want to do all of our possibilities. We got to figure out that p over q, right? P again is all of the factors of your last term, which is 15. So plus and minus 1, plus and minus 3, plus and minus 5, and plus and minus 15. And q is the possibilities from your leading coefficient, plus and minus 1 and plus and minus 2. Okay, so what we're going to do next is we have to think about this basically as a list, right? We get 1, -1, 3, -3, 5, -5, 15, -15. And then we have 1/2, -1/2, 3 halves, -3 halves, 5 halves, -5 halves, 15 halves, -15 halves. So those are all of our possibilities. Now again, we're not going to want to test all of those. So what we're going to do is we're going to graph it real quick just to get a general idea of what it looks like and what zeros I should test. Okay, so this is what I want to use. Okay, we're going to add a graph page. Put that in. Okay, and really it's not a pretty one, so I'm going to zoom out just to get a better idea, but it's kind of ugly. Okay, oops. Let's make this, I don't know, 80. And okay, so here's the general look of it. All right, so we got to kind of figure out what we want to test. And I want this scale to be 1 so that it's easier to see. It looks like it's between 2 and 3 and between -2 and -3. So between 2 and 3, between -2 and -3.
Are those
Also between 0 and 1. Okay? So I guess the first one I want to look at would be that positive 1/2. Okay?
can't exactly fix that. The size of your hands.
Okay, so we're going to start by testing the value of 1/2. Stop it. Okay, so our coefficients are 2, -1, -4, 2, -30, and 15. I'm going to drop that value of 2. 1/2 times 2 is 1. -1 plus 1 is 0. This becomes 0, -4, -2, 0, 0, -30, and -15, 0. Okay, since this value is 0, we know that 1/2 is a factor. Okay, so that allows us to begin factoring it as x minus 1/2, and then our quotient here. So this is your constant, x squared, x cubed, x to the 4th. So 2x to the 4th, 0x cubed, minus 4, I said to the 4th and I wrote squared, sorry about that, habit. 4x squared, 0x, minus 30. Okay, let's make that pretty. So there's our first step. Okay, so now if I look at this, I can actually pull out a GCF of 2. Then if I look a little bit further, this is also factorable. Okay, starts with x squared, plus and minus. Two numbers that multiply to be 15 and add to be 2 would be -5 and 3. Okay, so now I've got it completely factored. So this is my linear factorization. So my last step is to find those rational zeros. So we get x equals 1/2, x squared equals -3, x squared equals 5, so we get x equals 1/2, x equals plus and minus the square root of 3i, x equals plus and minus the square root of 5. So I actually have 2, 4, 5 solutions there, and all 5, so that matches the degree of my polynomial, which is the 5th power. Okay. So the last thing I need to do, I'm going to factor it a little bit further now that I have the zeros. Okay. Don't forget the 2 that I had. X minus 1/2, x plus the square root of 3i, x minus the square root of 3i, x plus the square root of 5, and x minus the square root of 5. And that's completely factored. Okay, so we have one more video with this lesson. We're all set with this one, so come in with any questions. We'll see you guys tomorrow.